Hi everyone, today I would like to present you the software Pick and Place Easy developed by our company ADiS Music GmbH. The idea to extend the features of the pick and place machine Neoden YY1 arose when assembling printed circuit boards involving big amount of components on both layers. It is, for example, the case for our motherboard you find in the devices involved in our solution for classical music, mezzo, da capo, maestro and audio synchronization system. The main purpose of the software is to avoid as much as possible long-lasting manual data entry during the setting phase. This in order to generate all the pick and place files involving the assembly of both top and bottom layers. The software manages up to 10 passes for each layer. It applies at present time to boards designed with Altium Designer but can obviously be extended by ADiS Music to other PCB design software. For this purpose, please contact us on the email address given at the end of the video. Let's dive a little bit deeper into the concept. The software is divided into 5 parts. General settings, components and feeders, about, help on settings, help on components and feeders. For this first video of the series, we are going to speak about the general settings. By clicking on the first command button, the General Settings tab lets you enter the folder and the file name for the Altium Pick and Place file. This is the CSV file exported from Altium Designer. The Help on Settings describes the columns and their order of the CSV file to be exported from Altium. Dimensions of the components can be stored in millimeter or inch. For this presentation, we are going to enter the Altium CSV file for the Mezzo docking connector board from the ADiS project. This is a 2 layers board used on Mezzo 1 and 2. By clicking on the second command button, the General Settings tab lets you enter the folder and file name of the Neoden output file. This is the CSV output file written by the software on a SD card to be inserted into the slot of the Neoden YY1 pick and place machine. The software automatically generates a file format offering full compatibility with the machine. By default, the software applies a default file name, Neoden YY1.csv. For this presentation, we are going to enter the folder and file name where we want the Neoden output file for the Mezzo docking connector board. We suggest using the SD card folder. Then we have the first panel named Component Size in millimeter versus recognition modes. The first dimension introduced in millimeter lets define the dimensions under which the mounted components will be recognized with the standard camera. On a same approach, this is also the minimal dimensions above which the components will be recognized with the big IC camera. For this presentation, we are going to set the value to 8 mm. The second dimension introduced in millimeter lets define the dimensions under which the components will be recognized with the big IC camera. On a same approach, this is also the minimal dimensions above which the components will be placed without any recognition. For this presentation, we are going to set the value to 12 mm. Then we have the second panel, PCB dimensions. Following the presentation of the board in Altium Designer, we enter the length of the horizontal side of the PCB in millimeter. For this presentation, we are going to enter 80 mm for the other dimension, horizontal size of our Mezzo docking connector board. We then enter the length of the vertical side of the PCB in millimeter. For this presentation, we are going to enter 100 mm vertical size of our Mezzo docking connector board. Then we have the third panel, PCB orientation. We have 2 options. The orientation defined in Altium and the clockwise 90 degrees rotated orientation from the orientation defined in Altium. The second orientation is convenient when, for example, the size of the board prevents to place it on the machine following the standard orientation defined in Altium Designer. Then we have the fourth panel, mounting speed, allowing the entry in percentage of mounting speed for all components involved. For this presentation, we are going to keep 100%. The last and fifth panel, mounting layers, is an output panel only, indicating the layers to be populated on the board. A sample view shows the way to place the board on the pick and place machine for top and bottom layer, if any. The red square here reminds the origin of the pick and place machine. It is always the bottom left-hand corner. Setting phase can be time-consuming, especially for printed circuit boards with huge amount of components. Our software Pick and Place Easy allows you to split the setting phase in several sessions. For that purpose, we have introduced the possibility to save the configuration at each step before exporting the files to the Pick and Place machine Neoden YY1. This is achieved here by the command button Save under Configuration. When re-entering the software Pick and Place Easy later, it is then possible to open a previous and unfinished configuration by hitting the command button Open under Configuration. The command button Quit allows to quit the software. In order to avoid any data loss, we strongly advise to save the configuration before quitting. The command button's other job and convert will be described in another video of the series about pick and place files generation. Feel free to click on the thumb up if you like this video. You can also subscribe if you don't want to miss any video from our channel ADiS Music GmbH. In the next video, we'll present the tab components and feeders. Thanks for your time and see you soon.